In this video, we are going to focus on horizontal access control, one of the most critical parts of application security. First, we will briefly understand what access control really means in a backend application. Then we will break it down into two important categories, horizontal access control and vertical access control. Then I will show you a real-world API-style demo of horizontal access vulnerability exists in our application, and then we see how to fix this problem. First, quickly understand what access control really means. Access control is simply about deciding what resource a user is allowed to access or modify, or what is not. Like only admin role users can access admin page and functionalities. Other normal users can't allow to do it. Now let's look forward to different categories of access control. Horizontal access control deals with access between users who have the same role or privileges. For example, two same role users, let's say two users with a student role in an application. Technically, each student should be able to access their own data, not another student data in an application. But let's say if a student A can get unauthorized access to student B records by exploiting some vulnerabilities in the system, then it's a horizontal access control vulnerabilities. As an unauthorized access happens between two users of same role or privileges level. On the other hand, vertical access control deal with access between users who have the different roles or privileges. For example, a normal user can access regular features, but admin-only functionalities must be restricted. If a normal user can access admin-only APIs or admin panels by exploiting some vulnerability in the system, then it's a vertical access control failure. Now let's understand how a horizontal access control vulnerability can exist in our application. In our system, users with student role can log in and enroll in different courses available. After enrolling, a student should only be able to view the courses they personally enroll in. They should not be able to see which courses other students are enrolled in. However, in our current code implementation, this restriction is not properly enforced. Because of this mistake, a student may be able to access enrollment data belonging to other users. This type of issue exists in real-world applications. Now let's examine the coding mistake that caused this vulnerability and learn how as a developer we can fix it properly. Now let's see this in action. If you have not set up the project yet, start by cloning it from the GitHub repository. I will provide link in the description. Then run the command npm install to install all the required dependencies. Once the setup is complete, run the backend server with npm run dev command. You will see a success message if the server is running successfully. Now let's start by creating two new users in our system. We can do this by sending a post request to the API/auth/register endpoint using Postman tool on our local server. We are creating two separate users by sending the request twice with different users sign up data in the request body. This is same as like filling a sign up form in an application. If the request is successful, both users will be registered in the system. Now let's verify this in our SQLite database. Open your database and check the users table. You should see two new user records with the username student A and student B created. Both assign the default role of student. Now let's log in with the users we just created. Send a post request to the API/auth/login endpoint using Postman. Provide valid credentials for each user that used on registration. If the credentials are correct, the system will respond with a JWT token. This token will be used in the upcoming steps to make API requests as an authenticated user. Now that we have our JWT token, let's enroll our students in different courses. First, copy the JWT token you received when logging in as a student A user. Use this token in your API request, typically in the authorization headers. This ensures that any request sent from this tab is treated as request made by the student A. Next, let's check which courses are available. Send a GET request to the API/courses endpoint. In the response, you will see the list of available courses that student can enroll in. Next, let's enroll student A in some course. Assume we want to enroll student A in Intro to Computing course. From the course list, this course has an ID of 1. Now we will send a post request to the API/enrollment/enroll endpoint and include this course ID of 1 in the request body. Once the request is successful, you should see a response confirming that student A has been enrolled in the course. Now let's repeat the same process for student B. Switch to student B by using the JWT token received during the student B user login. Enroll student B in the software engineering course with course ID 2. After sending the request, you should see a success response confirming that student B has been enrolled. At this point, both students are enrolled in different courses, and our setup is ready for testing the vulnerability in the next step. Let's take a look at how enrollments are stored in the database. All users' enrollment records are stored in a single table. As you can see, this table contains enrollment of every user in the system with their enrollment ID, student ID, and course ID corresponding to the actual data linked with it. Next, let's see how a student view or access their enrollment from the backend. To get the currently login user enrollments, we use the API with endpoint API/enrollment/me. When you call this API, it correctly returns the courses that the login user is enrolled in. But now consider another scenario. What if a user have multiple enrollment records, but user want to access detail of a specific enrollment record? This can be done using this API/enrollment-ID endpoint, where ID represents a specific enrollment record. When we send this request with a valid ID, the API returns detailed information such as student name, course name, grade, and other related data. So far everything works as expected when we provide our own enroll course enrollment ID to this API. But here where the problem starts. What if we change the ID in the request? For example, instead of using our own course enrollment ID, we try a different ID or random ID, let's say 3. When we send this request, the API still returns data, but this time it may belong to another user. In our case, this is student B enrollment record data. But in this tab, we actually log in as student A. This is a critical security issue. This vulnerability is known as IDOR, Insecure Direct Object Reference, a type of horizontal access control vulnerability. It happens when an application allows users to access objects directly using user supply IDs without proper authorization check. As a result, attacker can manipulate IDs to access sensitive data of other users. This type of vulnerability actually found in many real-world applications. For example, instead of enrollment record, it could be chat messages or other sensitive data that become accessible by changing the IDs in the request parameter if this type of vulnerability exists. Let's start by looking at the enrollment routes in our application. Here you can see a route that handles a GET request with an ID parameter API/enrollment::ID. This route is connected to the getEnrollmentById controller function, which actually contains the logic for handling this request. Let's open this function and analyze what's happened. You can see first the function extracts the ID from request.params.id parameter value. This ID comes directly from the user request. Next, SQL query is executed using this ID to fetch the corresponding enrollment record from the database. If no record is found, the API sends a 404 response. If the record exists, it returns the enrollment details to the user as a response. At first glance, this looks correct, but this is exactly where the vulnerability exists. The issue here is that there is no validation check to verify whether the requested enrollment record actually belongs to the login user. This means any user can manipulate the ID and access another user's data. To fix this, we implemented a proper authorization check. Each enrollment record is actually stored with the user ID of the student who owns it. When a request comes in, the backend checks two things. The login user ID and the user ID in the record are same. If the both IDs match, the system allows access because the data belongs to the user. If the IDs don't match, the request is immediately blocked. This way, user can only access their own data, preventing IDOR attacks. Let's try to fix this in our code. First, check the role of the user making the request. We apply this restriction only to student user, since admins are allowed to access any enrollment record in the system. Now let's add the main ownership check. We are comparing the login user ID in request or user.id with the user ID of the enrollment record fetched from the database. If the IDs don't match, return an error. If they match, return the enrollment record data as a response. This ensures that students can only access their own records. A more efficient approach is to include this authorization check directly in the SQL query. This avoids extra logic and improves performance. However, for simplicity and understanding, we implemented it separately. I will provide the query version as well in the GitHub repo. With this fix, we successfully prevent the IDOR vulnerability in this endpoint. Now let's test our fix by making the API request again to fetch a specific enrollment record. Let's try accessing the login user own enrollment record first. We are making the request as a student A in this step. First send the request with the enrollment ID belong to the requested user. You should receive a successful response with the enrollment details. This confirms that user can still access their own data, which is expected behavior. Next, let's try to access an enrollment record belongs to the another user. Change the ID in the API request to a different user enrollment ID. Send the request again. This time you should receive an error message. You are forbidden from accessing this record. This means our fix is working correctly. We have successfully implemented unauthorized access and fixed a critical IDOR horizontal access control vulnerability in our application. In the upcoming video, we will go through a complete guide on how to prevent horizontal access control vulnerabilities in real-world applications. If you face any difficulty while setting up the project, feel free to contact me. I will try to help. If you found this video helpful, don't forget to like and subscribe to the channel for more content on application security.